and good afternoon to all the participants of this very important course. Now today in this talk I am going to just speak to you about the other dimension of India's space program, that is mainly about the space exploration. You must have heard some talks about the Earth observation program or the satellite systems which are being launched for studying the Earth. But apart from studying Earth, we are also have launched two very important mission profiles. One is for studying the moon, and then of course you also must have heard about a mission, ISRO's missions to Mars, or which is known as Mangalyaan. In fact, there was a famous movie also on the efforts of ISRO towards for Mangalyaan mission or the Mangal mission. So the title of my talk is Mysteries of Our Solar System Through the Eyes of Indian Planetary Exploration Program. Now, as all of you are aware, we live in this universe which has large amount of galactic systems, and then of course in each of these galaxies there are multiples and millions and billions of stars are there, and around those stars countless solar systems are there. But in our solar system, our star is Sun, and then of course we have this inner planets, Mercury, Venus, Earth, Mars, and then Jupiter, and then you have this the outer planets, Jupiter, Saturn, Uranus, Neptune, and then there are also some smaller planets which we are basically calling the dwarf planets, and now Pluto has also gone into that. And then these four small inner planets, basically they are also known as the terrestrial planets, and then four big outer planets, they are basically called the guests or the icy giants. This is a general common knowledge, all of you are aware about it. And you can see their relative sizes also when compared to the size of the Sun. The Earth is basically situated at a location which is not very far from the Sun and not very close like Mercury and Venus, which are very experiencing very hot environment due to proximity of Sun. So Earth is placed at a very optimal place. And then of course the next close door neighbor to Earth is Mars, which of course is much smaller to us. And then these big giants are there. Of course, I'm not going to talk much about them, but we will be today talking more about Mars and Earth's own moon, because each of these satellites also have their own satellites. Each of these planets also have their own satellite systems, and Earth we have our own one single natural satellite that is basically called as moon. So ISRO started exploring about the outer space and the planetary activities since its inception, and then more emphasis basically came with the launch of Chandrayaan-1 mission. Many of you must have heard about the first lunar mission called as the Chandrayaan, and then the previous late Prime Minister Vajpayee Sahab, he also put a number against it. It's called Chandrayaan-1. That means we should not stop by sending one mission to moon. There has to be multiple missions where basically the knowledge about the moon must get enhanced, and ultimately people are talking about making moon as an outpost or the human outpost. Already humans have visited moon, but for various reasons, I will tell you those reasons, it will become important in times to come to have some presence on the moon also. And then the second mission, which was a pure interplanetary mission called Mars Orbiter mission, also basically provided a very great emphasis on the planetary science and exploration activities. We also have done in 2019 Chandrayaan-2 mission, which was basically a landing attempt. There was a lander rover configuration was there apart from an orbiter, and now we are talking about a follow-on mission to Mars. It's called Mars Orbiter mission, and then a mission to Venus also is being discussed and debated. Now instead, in order to study these missions, these planetary bodies, you need to send a satellite which can revolve around them. You need to develop ground segments or the infrastructure on the Earth itself, so that the data or the signals which are basically sent by these satellites can be received from a very far off distances, and then we can generate information about some of these objects which we are basically studying. So the basic objective of such missions is to understand and expand our knowledge about the environment around these planetary bodies, and then in general, more knowledge about the solar system and beyond. Even people are sending large amount of telescopic, systems like Hubble telescope, or even now recently you must have heard about James Webb telescope, to know more mysteries about the universe. But today we are going to talk more about the solar system alone. Now, initially I will talk more about our own Earth's, natural satellite, which is known as the moon. Now, what is our interest in moon? Every day we see moon whenever it is there up in the horizon, and we see different phases of the moon depending on the sun, moon, and Earth's orientation. You have the full moon day, you have the new moon, and then you have different phases of the moon depending on the kind of sun, moon, Earth angle and the time on which you are observing it. Now, as far as the interest about the moon is concerned, there are varied interest to know more about moon, because not only it is the largest, it appears to be the largest celestial object as we see from the naked eye. There is also large amount of inquisitiveness, that since it is only 384,000 kilometers away from surface of the Earth, why it is so different. It appears in a different color compared to the color of the Earth. What you see from space is more blue. Earth is known as blue planet, but the moon is basically a shades of gray. So there are 4 major scientific interests out there. One is basically we want to know that how moon has formed, what kind of processes through which moon formation has happened, what was the early environment when the solar system was evolving, and what type of processes were there on the early Earth moon system, because Earth basically has undergone large amount of changes because of different processes like plate tectonics, etc. But on moon, many of this early solar system history of the early solar system is stored on the moon. Then currently, if suppose you want to go to moon, what kind of environmental conditions are there? Suppose if a human goes to moon surface, if we land a rocket or a satellite onto the moon surface, what kind of environment you will face, whether it is similar to Earth or it's very different to Earth. And then of course moon also has large amount of the impact craters. That means large amount of meteorites, they have hit the moon surface, and I will show you the pictures of the moon where you can see the impressions of these meteoritic impacts on the moon, and they also tell you the history about the chaoticness of our solar system. So to study these kind of scientific interest, ISRO conceived a mission with multiple agencies in the country as well as from other agencies from abroad, and this mission was known as Chandrayaan-1 mission. And Chandrayaan-1 mission was a truly international class of a mission. There was participation from NASA, there was participation from European Space Agency, there were participation from Bulgarian Space Agency, and of course there were something like 11 scientific experiments were planned on this Chandrayaan-1 mission. Don't worry about these technical names, but mainly they were categorized into 2 or 3 categories. One is basically to take the photographs or the very high resolution images of the moon surface in from different angles. Then of course there were instruments which were taking the reflected images or the reflected sun's energy they were measuring in different parts of electromagnetic spectrum. This is called the spectrometers. And then of course we had some other experiments in the microwave part of electromagnetic spectrum. That means they are supposed to make measurements in the microwave region to know something more about where the sun's light does not reach on the moon surface. And of course there was a moon impact probe. That means from the satellite a probe was built actually and was put on the satellite, and when the satellite was going around the moon, this probe was released and actually it has fallen onto the moon surface. And while it was falling, it was also taking some measurements, and it was also having the India's flag painted on it. So in a way you can say that India's flag was also established onto the moon surface where the moon impact probe has landed during this Chandrayaan-1 phase time. So large amount of satellite data, large amount of images of the moon were captured by this satellite, which was operated only for 9 months period. In fact, this mission was supposed to last for 2 years, but due to some technical, glitches, after 9 months it stopped working and stopped producing the data. But whatever data it has sent, it has provided, large amount of information about the moon surface. And many of you must have heard about this famous discovery of that Chandrayaan-1 found water on the moon surface. I will tell you that story of water also. Then, of course, it also, found some very interesting geological features on moon. You can see one such feature. There is a line on the moon surface. So this type of, signatures or this type of features on Earth are normally known to be associated with some kind of either volcanic activity or some geological processes like faults and folds. So similar type of features were also observed onto the moon surface. And then there is another hypothesis. It's a technical term called global magma ocean. It basically means that the moon has evolved through a process of very hot molten body, and then slowly it has got solidified. And while a hot molten body over a period of time gets solidified, it also leads to a very typical type of rock mineralogy. And that's what basically was established by this Chandrayaan-1 mission. And we found a signature of the rock, which is basically composed of lighter elements compared to the heavy metals which are found in the interior part of the moon surface. So these were the 3 major scientific achievements of this Chandrayaan-1 mission. If somebody has to summarize it in one slide, I can say that it basically changed the perspective of lunar scientists in a dramatic manner. What was the understanding of moon before Chandrayaan-1 and the understanding of moon after Chandrayaan-1, there was almost a 180-degree shift has come because of the knowledge which was created or produced by this Chandrayaan-1 mission. Now I'll show you some of the beautiful images which was produced. Now this is how the moon looks, this particular part of the moon which is visible from the Earth's surface, But as you know, moon is also a sphere like Earth, and on Earth we have the eastern hemisphere and western hemisphere. So, the part towards like India is located, and on the opposite side we have United States of America and then Latin America, and also same way there are 2 spheres of this sphere. So the part which we see from the Earth is normally known as the near side of the Earth, a near side of the moon. And this is what is the side which we see from Earth. We never see this back side of the moon from Earth's surface. It is not possible to see, because what is known is a phenomena called tidal locking of the moon. That means the amount of time which moon takes to spin on its axis and the time it takes to rotate around Earth is more or less similar. So that is why from Earth, from a location, you cannot see the back side of the Earth. But for the first time, the satellites basically which were going around the moon, they imaged the far side of the moon, and people realized that how different the far side of the moon is compared to the near side. You yourself can see, as a layman, you can see there are big impact craters, there are dots, there are undulations, there are darker features, there are brighter features. But on the back side of the moon, these brighter features are more compared to such darker features. And then, of course, there are a large amount of this small dots are also there. There's small dots, big dots. So these are all basically nothing but the record of the impact craters. That means since moon does not have atmosphere, most of the meteorites which are there in the solar system, they simply go and hit the moon surface. And then once they hit the moon surface, such type of impressions are created. And these impressions are known as the impact craters. So there are impact craters which are small, big and bigger, and then there are huge impact craters also there. What you see is one more dark material here compared to the far side, and this dark material is basically, there are a lot of stories you must have heard about somebody sitting on moon, weaving some charkha or something like that. But there is nothing like that. These are all the rocks basically which absorb sunlight. Most of them have very high iron content, and they are known as the basaltic rocks. On Earth also, in India, we will find these basaltic compositions, that black cotton soil, which are more famous in Maharashtra and in Gujarat. They are basically basaltic soils, but here you have the basaltic rock exposures, and that's why these regions of the moon, they appear much darker compared to the brighter rocks, which are basically made of lighter elements like silica, calcium, and then aluminium, etc., etc. So these are the two basic differences on the surface of the moon. There is not many other shades. You have dark shades and some less dark shades. That's all. There are no blue color, no red color, no white color. These are all color photographs. In fact, this is not a black and white photograph, but we hardly see any color variations on the moon surface. Now, the basic questions which one need to ask is, how did our moon has formed? What has been happening since this formation? And then what kind of resources are found onto the moon surface. So I'll talk about more in the impact craters. You have seen this moon surface looks so battered, and it is full of impact craters. Our poets, they say that moon is so beautiful, but when you look moon from very close, distance, that's how it looks. It doesn't look as beautiful as we see from the Earth. Now that is mainly because of this meteorites. When a meteorite approaches moon surface, since there is no atmosphere on the moon, in Earth's atmosphere, many of these meteorites, simply because of friction, they burn out, and by the time they reach Earth's surface, they are too small to create large impact craters. But that facility is not, or that cushion is not there on the moon surface. These meteorites, they come and they crash unhampered, and as soon as they crash, they create this transient cavity. This phenomena is known as transient cavity, and large amount of material is splashed out, and then immediately, within no time, this entire process stops, and this huge amount of dots, or you can say the craters or impact craters are formed. In fact, if the meteorite size is very large, then you form what is known as a complex crater, and some of these craters will also have this central hill. Mostly for moon craters which are having diameter more than 25 kilometers, you will find a very nicely developed central hill. So this type of craters are called complex craters. So these are different type of craters you can find on the moon surface. You have micron size of craters, which are basically caused by the fall of the dust particles or even the intergalactic dust. Then you have craters which are less than 1 kilometer size, very small craters. They are also formed due to the meteoritic impacts. Then of course you have this complex craters more than 25 kilometers or so. There is a crater called Euler crater. It has a diameter of 28 kilometers, but a beautiful central rise is there in such type of craters. And then you have peak ring basins also, which are basically of the order of around 300 to 500 kilometers, where you will have multiple rings actually. And then you have multi-rings basins also, like Oriental Basin on moon, which is having a diameter of around 1000 kilometers or so. So this has evolved over a period of time. So such a huge phenomena of impact cratering you can observe on the moon surface. I'll show you some of the photographs which have been taken by our Chandrayaan-1 mission. So this is a nice photo. It's called a dark haloed crater. This is around 5 kilometer diameter crater, and around this you can see a dark ring also. And such craters on moon are called dark haloed craters. But there are small craters also, and they are known as ray. You can see that some rays are propagating outwards from the center of this crater. Now, one interesting thing is that you will see that wherever there is an impact crater, you will see white color. And as you move out from this crater, you start seeing the shades of gray. Why it happens? There is a phenomena called space weathering. So the older moon surface appears much darker, and if you disturb the older surface, the surface which is below the top layer, it gets exposed, and then these surfaces have less amount of space weathering, and they appear much brighter or much fresher compared to the dark space weathered surfaces. Now this is another important crater. It's a beautiful photograph which you can see, which has been captured by our Chandrayaan-1. If you see from your naked eye also moon, in the southern hemisphere of the moon, you will see a small circle with rays, going out of this circle. And this particular, crater is known as the Tycho crater. It has been named after a famous astronaut called Tycho Brahe, and this has a diameter of roughly around 85 kilometers with a beautifully developed central peak. And using our terrain mapping camera, which has capability to view different angles, we have also reconstructed the three-dimensional topography of the central peak of the Tycho crater, and this is what it looks like. It looks like a hill only, and then you have depressions, and then you also have seen material falling out from some of these tracks over here. There are floor fractures at the crater floor. So you get a totally different perspective of the moon surface when you see it from the close quarters. Then around this crater, there are also features called impact melts. Impact melt is what, since this meteorite, they crash onto the moon surface with high amount of velocity, they also impart large amount of kinetic energy, which basically instantly melts these rock masses or the parent rocks, and some of this melted rocks, they start flowing. Now what you see here is a photograph of an impact melt which has been frozen in time, because now it has been solidified or cooled down, but still you can see the ripples or the wave type of features are still intact and they have been frozen in time. So this type of beautiful phenomenons can be observed onto the moon surface, which has been caused by this impact melt or the impacting process, which creates this type of landforms. Then another type of landform on moon is like what you see is like a snake type of a object. In fact, it's not a snake, it's a kind of a channel where basically the ancient magnetism has happened or volcanic activity has happened, and then this is a kind of a depression. If you see, with some, if you stare over this image, right now you may be seeing it's a protrusion, but it's not protruded thing. It is a depression over here, and then this is the uncollapsed part of this depression. So mostly these features are known as the lava tubes, where during the volcanic activity the lava has flown, and once the it basically cooled down, the top surface collapses and you get this type of formations. These are known as the lunar lava tubes or the sinus rills actually. So these are some of very interesting landforms which I showed you, which are seen from the eyes of Chandrayaan-1. Then we also have this spectrometers. That means we have an instrument which has capability to record reflected energy in different part of electromagnetic spectrum. And if you make measurements of this reflected energy, you will see there are a lot of ups and downs are there as a function of wavelength in terms of reflected energy. And these absorptions or the depressions in this type of curves are basically tells you about the composition or the property of the lunar rocks. And the scientists basically they interpret or they get inference about the minerals which are present onto the moon surface. So on Chandrayaan we had this 3 instrument which was supposed to tell you about the composition or the kind of rocks and minerals which are present onto the moon surface. So using this data, a broad general mineralogical map was created. So wherever you see this red color, they are basically the bright or what we call as the highland rocks. They are, in geological terms, people call them the pyroxenates actually. Plagioclase rocks. And then wherever you have this blue and green combinations, these are basically the basaltic rocks or the rocks which get formed in the interior of moon, but because of the impact crater process, they have come onto the surface of the moon. So that is how the composition of the moon has been derived using these Chandrayaan-1 data sets. Then of course, there was also a story about the water on moon. In fact, during Apollo time frame, when the humans have landed, they also brought large amount of lunar samples back to the Earth. And then scientists in America, in Europe, and in India also, they got these samples for analysis, and then they did thorough geochemical analysis. But those days, especially in 70s, early, instrumentation was not very developed, and they could not, they found that there is nothing, in terms of water in these returned samples. But slowly, as the instrumentation also developed, people started analyzing this volcanic beads or the return samples, and they found traces of water around 46 ppm, which is a very small amount of water in these type of return samples. And later on, using our Chandrayaan data, we also found that there are some spectral signatures in terms of absorption of light at certain wavelengths, which basically happens if the water is present or the water molecules are present onto any surface. And then we map this presence of water molecule, and to our surprise we found that the polar regions, both the North Pole and the South Pole of the Moon, has pretty rich abundance of the order of 1000 ppm. Water molecules are found onto the Moon surface. It is not the water in our rivers or something like that. This is a kind of adsorbed water in the dust of the polar regions of the Moon. So don't think that if you go on rivers of water, this is just an adsorbed or a very, very thin layer of water in a molecular form, which is basically spread. But this itself was a big discovery, because previous to this, people used to think that Moon is bone dry, there is nothing, there is no presence of water molecules on the Moon surface. So I will not go into these technical details of this discovery, but this is what is this absorption features, which I am talking about. And these absorption features, if you detect, these are indicative of presence of water at different locations on the Moon surface. And of course, we found some very young volcanic complexes also onto the Moon surface, which I will show you later on. Also, some of the examples. Now, this type of very unique, pits formations are also seen. These are basically sinkhole kind of things. And in different regions of Moon, you also see different type of sinkholes, which can be used for hiding and then getting protection from the, the solar wind or the harmful radiation of the sun also. Now, Chandrayaan-1 provided such a large amount of information, it basically added to more curiosity from the scientific community, and they wanted, because the mission only survived for 9 months, then newer missions were basically planned, like Chandrayaan-2, then some of the Chinese missions like Chang'e 4, 5, Russians also have this lunar series of missions, Japanese also have their missions to Moon. So large amount of, interest is there now, in the human community to know more about the details of the Moon. And of course, as I told you, these are all rocks. Most of the rocks, especially the darker rocks, are rich in heavier elements like nickel, iron, cobalt, and then of course we also have trapped helium onto some of the ilmenite rocks. So the race is now to know the resources of the Moon, and then in future, as our population is growing, the Earth resources will be basically depleting, and we may have to, if the day may come, then we may have to get some of our requirements, and mineral resources or mineral requirements will be met by doing exploration of the Moon surface also. So considering this, ISRO also launched it's a new mission to Moon in 2019 called Chandrayaan-2, and this time we thought that we will not only go around the Moon, we will also try to attempt a landing onto the Moon surface, because previously Americans, as you know, they have landed humans, Russians have also landed unmanned missions, and Chinese have also now landed their rovers onto the Moon surface. So keeping in trend with the International Space Agency, ISRO also conceived a satellite called Chandrayaan-2, which has this configuration of a lander, and once it lands onto the Moon surface, a rover will come out, and then it will move around the Moon surface and do certain experiments to know the rock type compositions, etc. of the Moon surface. So this is how the entire spacecraft looked like. This is the orbiter. This is supposed to go around Moon, and then lander was supposed to land, and it will communicate with the orbiter. And once the lander lands, it also, a rover will come out, and it will also do certain experiment. So this was launched on July 22, 2019, but due to certain reasons, this lander, it crashed at around 200 meters above the surface of the Moon surface, and because of this unsuccessful landing attempt, even the rover could not come out of the lander. But we still have successfully this orbiter, which is going around the Moon surface and providing very important data about the Moon surface. Okay, so there are different type of scientific payloads or scientific experiments are there onto Chandrayaan 2, orbiter also. I will not go into details of it, but most of them are related to imaging moon in different part of electromagnetic spectrum and finding more signatures of water, confirmatory signatures of water. Then there is a radar system is also there to know about the story of water ice in the permanently shadowed polar areas of the moon. And then of course on lander and rover we also have certain experiment, but anyway it did not work, so I will not talk much about it. So this is how the first set of images started coming from our Chandrayaan 2, and you can see this is a image taken from a distance of around 2,600 kilometers from the moon surface, and you can see the large amount of impact craters, and then there's a huge basin also is there, which is basically multi-ring basin. And then one very interesting thing you can see that some of these craters are aligned in one linear pattern. There is a huge amount of craters which are aligned in linear patterns, and these craters are called as the secondary craters. That means a primary impact crater happens, and then some material is ejected and it goes into the air, and then it also flies off, and then this ejected material again drops in certain patterns, and this forms what we call as the secondary impact cratering process. So you can trace some of these secondary impact craters, and also people are back calculating and then also are able to make information about the size of the impactor, the angle of which it has approached, and what kind of impact cratering process must have happened by analyzing these patterns of secondary impact craters. So these are some of the images from Chandrayaan 2 data. You can see again a impact crater with central rise. Then again so many impact craters are seen. Then we had this another beautiful instrument called the spectrometer, imaging infrared spectrometer, which was operating from 0.8 to 5 micron for the first time. In the thermal part of the electromagnetic spectrum also we built a instrument, and this is the instrument again through which we have confirmed now the presence of water at multiple locations in a much more realistic manner. This is again a 3D view of the moon. You can see this type of landforms which are there onto the moon surface. This is an image from dual frequency synthetic aperture radar, where you have the capability to penetrate into the moon surface, and whatever material is below the surface, that also can be seen in these images. Okay. Now this is something about the about the moon actually. I can talk and talk, but time is limited. Otherwise, I could have gone on and showed you so many. We have a compilation of large amount of images on the moon, and it is if you Google Lunar Science Atlas, you will get a beautiful book which is contributed by us at our team, and then you can just go through this, and then large amount of images about the moon from Chandrayaan 1 mission are basically put in that particular atlas. Now I'll just briefly talk for next 10-15 minutes about this Mars also. So we have also done exploration of Mars, and Mars, as you know, is known as the red planet. इसको लाल ग्रह भी बोलते हैं. मंगल को लोग ऐसा सोचते हैं. People think that it's very hot, that is why it is red, but it's not. It's not a hot body. It is red because of the kind of dust or the kind of rock masses it has over it. But if you see the average surface temperature, they are basically minus 63 degrees Celsius. So in fact, it is a much cooler body compared to Earth, because it is far away from the sun, and it also has beautiful polar ice caps both at the North Pole as well as the South Pole. It has a CO2 dominated atmosphere compared to Earth's nitrogen dominated atmosphere. The problem is that on Mars, the Earth's the atmosphere's density is very less. It's only 7.5 millibar. So very low atmospheric pressure is there, and of course it is much smaller, almost half the size of the Earth, and then it is 1.5 angstrom unit away from the sun. Its gravity is also low because its size and mass is less, and then the length of the day is almost same, but the length of the year is almost double than what we have on the in the case of Earth. And of course I talked about the surface temperatures are not as comfortable as we have on the Earth's surface, and it's tilted around 25 degrees on its axis, so it has some seasonality also. And unlike Earth, where we have only one well-developed moon, there are two small, bodies which are known as Phobos and Deimos. They go around the moon and they are considered the moons of the Mars, but they are very, very small bodies compared to the moon of Earth actually. So we have similarities with respect to Earth. It has season cycles. We have thermally, conducive environment, and then similar type of landforms. I will show you some pictures of landforms of Mars. Atmospheric layers, unlike moon, but the atmospheric density is much, much lesser what we have on the Earth's surface. And then we have very clear unambiguous evidences that water must have been flown on the surface of Mars sometime in the geological history, but today there is no flowing water or no liquid water which sustains onto the Martian surface. So what is the interest? There are a lot of interest in studying Mars. The movies have been made. People are thinking of terraforming Mars. They want to change the entire Mars surface so that people or humans can live it in that particular environment in times to come. So the basic reason is it is next closest planet to Earth, and though it is cold and dry today, it holds all the elements that are needed for life to exist. In fact, there are a huge amount of programs by NASA, ESA, and other space agencies to search life, of any form, even the bacterial form of life. If we get on the moon, on the Mars surface, it will be a huge discovery, because we have no knowledge about any possibility or any kind of life existing beyond Earth. So the Mars is the very good candidate for discovering any, maybe a bacterial form or a microscopic form of life. And then, of course, it is close to Earth. The length of the day is more or less similar. It has seasons. It has resources like water is a big resource. And then, of course, it is frozen on the northern and the southern pole because of the extremely low temperatures which you find in the polar regions of the Martian surface. Large amount of exploration has happened. So many objects have been sent by various space agencies. We call it, space scientists call it the family portrait, which of the satellites which has not only revolved around the Mars, but there are many rovers which has landed, and currently also some rovers are producing beautiful images on the Martian surface. Now this Mars orbiter mission, it was basically launched from our spaceport in 2013. Then it arrived after 1 year, because the distance is around 225 million kilometers. So it traveled almost for a year, and then it reached and entered into the gravitational influence of Mars, and then it started circling, around the Mars in a highly elliptical orbit of around 327 kilometers by 80,000 kilometers. So when it was closest to the Mars, it was 372 kilometers away, and when it was farthest from the Mars, it was around 80,000 kilometers away. And then it rotated, around 3 days. One rotation it was completing around the surface of the Mars. This is how the satellite looked. This is the antenna, communication antenna, and this is the main body of the satellite. This is the team which built this satellite, and then ultimately it was put onto a rocket, and then there was a takeoff or a launch on November 5th, 2013 from Sriharikota at in Andhra Pradesh, which is in the southern region of India. And then, of course, after 1 year, when it was launched, and then Earth was moving around the sun, and then Mars was also moving around the sun. You cannot simply jump from Earth to Mars. You have to basically go, along the gravitational influence of sun. And when the Mars comes, on its path, and your satellite is also moving towards it, when they come fairly close to each other, then you do a maneuver. It's called, the orbit insertion maneuver. The speed is reduced, and then the satellite is basically injected into what we call as the Martian orbit insertion capability, and then the satellite starts going around the surface of any body wherever you want to establish. So planetary, travel is also very, very interesting, and how you go to different planets and what approaches you take, itself is a very interesting subject of research. And you don't get opportunities to go to Mars every day. There will be some very opportune time, maybe once in 2 years or once in 3 years, depending on the orbital positions of Earth and Mars, when you will have a appropriate opportunity to launch a satellite so that you can reach with minimum fuel to this type of planetary travel. So we have this 3 or 4 very interesting scientific experiments, but I will be mainly talking about this Mars color camera, which is supposed to take photograph of the Mars surface. I will show you some beautiful photographs of the Mars surface which was captured by our Mars color camera. Now you can see this is a whole planetary body, and when you see Mars from such a close quarter, you can see the details of different type of landforms which are there on Mars. This is the the ice cap on the northern ice cap, then the atmosphere, you can see the dust storms, then this pink or the red surface on the Mars, which basically gives it color, red planet look, that's why people call it. Then of course there are some shades of gray depending on the the kind of geology or the kind of rocks you have onto the Mars surface, and there are some kind of clouds are also seen in this particular picture. And then there are huge there are impact craters on Mars, but not as many impact craters as you see in case of Moon. So it's very different. So these are the different global photographs which was captured by this Mars color camera on different dates. So you see different type of phenomenon and on different type of locations depending on the surface type. The color of the Mars also changes. This is a very unique feature. This is called valleys of marinaries. This is a gorge or a canyon. Many of you must be teaching the landforms or the geological landform. Geography teachers must be aware about the canyon systems. So this is the largest canyon system in the solar system. Our solar system is around 3,000 kilometers long and then around 200 meters wide. And this is a very spectacular feature. In many of these images, you can see this huge, valleys of marinaries canyon landform seen very nicely. And then this is a much closer photograph of this valleys of marinaries. A part of it, you can see this walls of the canyon, and then the surface of the bottom of the bottom floor of the canyon, and then there are a large amount of impact craters are also seen around this canyon at the Mars. Then Mars, unlike the Moon, also has, I told you, atmosphere, and then large amount of dust, which basically gives this color. Like if you go to Rajasthan or Jaisalmer, you will find this, the orange colored dust there. So this dust, because of the atmospheric phenomena, it gets lifted up, and then large amount of dust storms and dust devils also do form onto the Martian surface. So this is one example we captured. Here you can see huge amount of dust, and then after 8 days we imaged the same area. This dust cloud has got removed actually. So you can see this, the surface below this dust storm. So that shows that the Martian atmosphere is very dynamic, and large amount of dust storms keeps on happening onto the Martian surface. Another interesting landforms on Mars are these huge volcanic complexes. You can see these 3 very huge volcanoes over here, and this is the largest volcano in the solar system. This volcano is known as Olympus Mons, and this has a height of around 25 kilometers or so, and they are so high in elevation that as those heights, even the thin atmosphere of Mars also starts condensing, and the cloud formation happens around this volcanic complexes on the Martian surface. So this is a beautiful cloud system which is getting developed onto this beautiful Martian complexes. This is a close quarter image of the largest volcanic complex or the largest hill in solar system called Olympus Mons, and this is the mouth of this volcano, and typically in geology they call it caldera, and these are basically the base of the mountain system, and the temperatures are so low that the thin atmosphere of Mars also starts condensing, and then this cloud condensate or very thin clouds are normally formed on these volcanic complexes. Then there are another interesting landforms on the Mars is basically you can see this type of channels. These channels basically gives the impression that some liquid must have flown onto the Mars surface, and in fact it is nothing but water. And you see this impression. This is the impact crater which has been cut off by the erosion process. So typical erosion patterns you will find onto the Moon surface, and this is another beautiful phenomena. It's called the North Polar Ice Cap, where fresh ice, both the CO2 ice as well as the water ice condensates are found, and this is a beautiful animation we developed from our Mars color camera about the north polar region of the Mars, where you can clearly see how the the polar ice is distributed, and it varies. There is large amount of seasonality is also involved with that. So this is in brief about our Mars mission, because I am already run out of time. It's almost 1 hour now. So what we have learned a lot about the moon surface. We have learned a lot about the Martian surface. A lot of people got excited about these missions. They know more now about these planets and then the processes which are going on these planets. We have also funded large amount of scientific research about these planetary bodies. ISRO has given a lot of funds to do some scientific analysis of this data. Now we want to return to Mars once again with much more scientifically oriented mission designs. And then there is also talk, the another neighboring planet of Earth is Venus, actually, which is very, very different compared to Mars, and it has very thick atmosphere. Mars has thin atmosphere, but Venus has very thick atmosphere. We cannot see the Venus surface from naked eye. Even if you put a satellite around it, you need to explore the Venus surface in microwave energy, because the visible and infrared light does not penetrate this thick atmosphere of Venus. There are some interesting facts about the Venus surface, that people believe that it has a sulfuric acid dominated atmosphere, which is basically getting generated because of the volcanic activity on the Venus surface. But we don't know much about these active volcanoes on Venus. So ISRO is contemplating a mission to study Venus in detail. Some early preliminary design studies and discussions with the scientific community is going on, and hopefully if everything is approved, then in next 3 to 4 years time we may have you may hear news that India is basically sending a mission to study Venus. So these are some of the interesting facts about Moon, Mars and Venus. And then I will leave you with this a very interesting image from the Moon surface. It reminds you about a bird which is found on Earth. It looks like more like a kiwi or a penguin with an eye and some beak and all, but in fact it's a volcanic complex on Mars, where you have this impact crater impressions and then some tectonically shifted landforms, which gives a beautiful impression of a bird sitting on Mars. But this is on a lighter side, but this is actually a volcanic complex. Many of these images from Mars orbiter mission also have been compiled and now available in the form of Mars Atlas. Some of you can download these documents from internet. With these words, I will stop over here, and I thank each one of you for your patience hearing. Thank you very much.